So today we are going to be looking at travel graphs. So travel graphs is a section that you can generally get some nice marks on. You don't need to learn very much about it, but you are going to have to actually look at the problem, try and understand a little bit, and probably interpret more than what you have to learn. So let us have a look. So, travel graphs. There are a few things that we need to remember about travel graphs from Foundation 1. Starting with, and let me write this in red. So, we need to know what is distance. Well, distance is essentially how far we are going. If you guys have any questions, I have the chat open, so feel free to type it in the chat. After distance, we have speed, which is how quickly we are getting there. And then we have time, which is how long it is taking to get there. Now, we need to be able to relate how to get between them. In other words, if you're given two of them, how do you deal with them to get the third one? So we need to also have a look at, well, what are the units that we're going to be dealing with? So distance is generally in kilometers. It could be in meters as well. Your time, I'm going to put in hours here. It could be in minutes, could be in seconds. Generally, we're looking at kilometers linking to hours or minutes linking to seconds. This is more scientific. This is more everyday based. And then speed is going to be generally kilometers per hour, but it could be therefore meters per second as well. Now, you might be saying, well, how am I going to remember this? How am I going to work this out? Well, there is a wonderful little thing, and it's got a horrible name. However, it is incredibly useful. And it is known as the idiot's triangle. Now, I'm not calling any of you guys idiots, and that's mainly because I use this triangle myself. So then essentially, I would be an idiot as well. So this idiot's triangle has speed over there, distance at the top, and time at the bottom. And the way that this thing works is if you want to calculate one of these three quantities, you cover up that quantity, and then the remaining part of the triangle will tell you how to calculate it. So let's just put in the units so that we can see how this is going to relate as well. So distance is in kilometers, time is in hours, speed is kilometers per hour. All right, great. So if we cover up one of them, so let's say we want to calculate speed. We cover up speed, and then that leaves distance divided by time. And that's how you calculate it. Speed equals distance over time. And that also makes sense because my units for distance are kilometers. My time unit is hour, and I'm dividing. So in essence, it becomes kilometers over hours. It's important to remember that your units actually give you everything you're going to need because they are derived from the actual calculation. What happens if I have something else? So if I don't want these, I can also calculate something else. So if I want to maybe calculate time, I then cover up time, and that leaves me with distance over speed, which makes sense because I've got kilometers divided by kilometers per hour. And then I can tip and times this fraction. So that is kilometers times hours over kilometers. Do you remember tip and times? You flip the fraction and change the divide to a times sign. Kilometers in the top, kilometers in the bottom cancel, and that leaves me with hours, which is the quantity I am looking for. So that is distance over speed. And similarly, if I want to calculate distance, I cover up distance. And now that I've got them next to each other, I'm going to be multiplying my speed by my time. So therefore, I have my units, which is kilometers over hours, being kilometers per hour, times by hours. The hours cancel because it's one on the top, one on the bottom. And that leaves me with kilometers, which is the distance quantity I'm looking for. All right. So this is how you use the triangle, but luckily most of the time you'll only ever have to really remember this one. The speed is distance over time. If you can remember this, you'll be able to come up with a triangle and then solve everything you need. In book 1, and I'm specifically starting at book 1, just to make sure that everyone has a good idea of how to use these graphs, we're then going to move from book 1 onwards to stuff that you would have then seen in book 2 and 3. This sort of thing does come about pretty much the same way in book 2, but I've specifically taken this example from book 1. And it talks to you about a family car journey. Let me change my color. All right. And it says, you've got a family car journey. You've been given a distance, notice specifically in kilometers, and time. Time hasn't been given a unit, but you've been given the actual time, which means you can see it's going up in hours. So the first question says, what time did the family set out? Well, set out means when did they leave? That's quite easy to see. It's going to be 7 a.m. How far do they travel in the first hour? Well, that's the first hour over there. So I need to measure up to here. Well, that is 50 kilometers. Great. What time, what is their average speed in the first hour? Well, remember, we know that speed is distance over time. So they traveled 50 kilometers in 1 hour, and 50 over 1 gives you 50 kilometers per hour. So that is my average speed. How long did they stop for breakfast? Well, we need to be able to see when did they stop for breakfast. Hopefully it's quite clear to see that they stop for breakfast here because their distance is not changing. Their distance from home is not changing. So therefore, in this time, they must have just stopped and are having their breakfast here. How long did it take? It took 1 hour. What is the average speed here for the second hour? Well, the average speed would be how far they've gone, which is 0, over the amount of time, which is 1 hour, and 0 over 1 is 0 kilometers per hour. How far did they travel between 9 a.m. and 11 a.m.? So that's from here to here. Well, they started at 50 k's away from home. They ended at 100 k's from home. Therefore, they traveled 50 k's. It's not 100 Ks because we're not starting at 0. We're starting at 9 a.m., which is at 50 Ks. Again, calculate your average speed. Well, average speed would be 50, but now this 50 is divided by 2 hours because it's from 9 up to 11. So that means it is 25 Ks per hour as an average speed. The family reached a motorway at 11 a.m. What was their average speed for the next hour? So here, my average speed, I'm going to have to calculate distance over time. My time is 1 hour. That's fine. But what's my distance? Well, I started at 100 there, and I finished at 200 there. So I've traveled 100 kilometers in an hour, which means my average speed is 100 kilometers per hour. So therefore, my average speed there is 50, there is 0, there is 25, and there is 100. What is the average speed? How long did the whole journey take? So the whole journey took from 7 to 12, which is 5 hours. How far did they travel in total? So how far? They started over here at 0, and they ended over here at 200, which means they traveled 200 kilometers. So therefore, what is their average speed for the whole journey? Well, speed is distance over time. And the distance was 200 kilometers over the time being 5 hours. And 200 over 5 is 40. So it's 40 kilometers per hour was the average speed if you were to just take it as one trip all the way to the end. Now, they then give you a second family. And the second family is now trying to get to the same place, but by train. And if it's by train, that means zoom. Train just keeps going straight through. There's no stops. So they leave at 9 a.m. and they arrive at noon at their destination. You need to show this journey on the graph. Well, that's going to be simply one solid line. No gaps, no deviations. There we go. What is the average speed of this train? Well, we should be able to even approximate what the average speed is going to be, because we see that this line is steeper than that one. You see it takes 2 blocks to go through. Here it takes 1.5 blocks to go through. But this line is steeper. So it should be somewhere between 50 and 100 Ks an hour. But can we get an exact value? Well, most definitely we can, because we know that they are going to travel 200 kilometers from 9 to 12, which is 3 hours. So 200 divided by 3 is 67.7 kilometers per hour, which makes sense that it's between 50 and 100. So this graph over here is now given us that it's speed in kilometers per hour and time. And this graph is in book 3, and it is page 115. Page 115. So this graph is also about the speed of a car during a journey. So let's get my color pen going. And it says to me, what time did the car set off on its journey? All right, when did it start? Well, it starts at the very beginning, 6 p.m. Great. How fast did the car travel for the first 30 minutes? Well, this one is halfway in between 60 and 40, so it's traveling at 50 k's an hour. Great. In a graph in the test, you would be able to know that this was exactly in the middle. Just the fact that I didn't have markings here is just due to my graph that I've drawn. How long did the car travel at 120 k's an hour? Well, here's 120 k's an hour because this is on my speed axis, and it's going from there to there, meaning from 6:30 to 8. That would be 1.5 hours. Half an hour, 1 hour, 1.5 hours. It then says, the driver stopped for a snack along the route. When did this occur? Well, to be safe, the driver is going to actually stop for the snack. And if he stops, what would his speed be? Well, to stop means your speed would have to be 0. And therefore, this is when the snack occurred. So at what time did it occur? It occurred between 8 and 8:30 p.m. How far did the car travel during the first half an hour? So the question is, how far did the car travel? So we are looking for distance. We have been given that the speed is 50 k's an hour, and we know that the time is half an hour. So you could work this out just intuitively to be 25 kilometers, because it's 50 k's in 1 hour, therefore in half an hour would be half of 50 k's is 25. Or you can use your triangle. It said speed was distance over time. So if I'm trying to calculate distance, it is speed times time. So it is 50 times a half, which gives me 25 kilometers. Exactly the same answer. And then you're asked, how far did the car travel on the whole journey? All right. So let's do not purple. I feel like doing orange. So over here, this is 25 kilometers. This is 1.5 hours at 120 k's an hour. So that's 120 times 1.5 hours. That is 180 kilometers. So 1 hour, he traveled 120 kilometers. And then another half an hour would be half of 120, which is 60. 60 and 120 make 180. How far did he travel here? He did not go anywhere because he stopped and had the snack, so it's 0 kilometers. And then over here, he's traveling for half an hour at 100 k's an hour. So 100 times a half gives me 50 kilometers. So how far did he travel in total? We add them together. 25 plus 180 is 205. 205 plus 0 is 205. 205 plus 50 gives 255 kilometers as a total distance.